Students, good morning. Today we'll continue the mechanism of ionic addition polymerization reaction. So in the previous class you are well familiar with free radical mechanism of addition polymerization reaction. Okay, today we'll discuss the ionic polymerization mechanism of ionic polymerization reaction. The first point is ionic polymerization is very selective. That means not every monomers can be polymerized by ionic polymerization method. That means only those monomers, only those alkenes which are having substituted groups on the carbon of double bond, they can undergo ionic addition polymerization process. Okay, so under ionic polymerization there are mainly two types: cationic polymerization and anionic polymerization process. So today we'll discuss about the cationic polymerization process. So here the alkenes with the electron donating substituents, alkenes with electron donating substituent groups on the carbon of double bond, they undergo cationic polymerization, and alkenes with electron withdrawing groups. So the substituents groups are having what nature? Electron withdrawing nature. Such groups, if they are present on the carbon of double bond, those monomers undergo anionic polymerization process. Okay. So I think you are well familiar with electron donating groups and electron withdrawing groups. Okay. So for your study they have mentioned, see the 4 examples already have learned. The first one is polyethylene, and where the mechanism involved in the polymerization is free radical polymerization mechanism or method. See, that means under free radical mechanism we can take polyethylene to explain the different steps. Okay, and the second one is polyvinyl chloride. Is it? Say that can be explained according to anionic polymerization process. And the third one is polystyrene, so which can be explained according to cationic polymerization method. And the polystyrene is also explained according to the third one, that is coordination polymerization reaction. Okay, process. So now today we'll discuss with cationic polymerization mechanism. See here, the electron donating groups are like, say, methyl, ethyl or ether groups or phenyl groups. They are acting as a electron donors or electron donating groups. Okay, so now under cationic or anionic, once again there are 3 steps as you have seen in the free radical mechanism. So the first step is said to be initiation step, second one is propagation step, and the third one is termination step. So in the initiation step, the first one is preparation of initiator, then the preparation of active species. So in the cationic, the active species which is first formed with the monomer is said to be a, or it is the active species is the carbanium ion, or it is also known as oxonium ion. Okay, that is the active species. So in the anionic, carbanion, that means negatively charged species, it is a active species which carries on the propagation or lengthening of the chain or addition of successive addition of monomers will be taken up by the carbanion. And here carbanium ion or oxonium ion or carbocation are the active species. So under initiation step, first the initiators are produced. So these are said to be initiators. Now usually Lewis acids are preferred to act as a catalyst which are acting as a catalyst in presence of water which acts as a co-catalyst. Say Lewis acid acts as a catalyst in presence of water as a which acts as a co-catalyst, or water is an initiator and Lewis acid is a co-initiator. Even like this also we can explain. Say Lewis acid as a catalyst and water is co-catalyst, or water is initiator and Lewis acid is a co-initiator. In the first step, say the Lewis acid, when it is made to react with the water, it produces a initiator, or it is a adduct complex. Okay, proton is released and it is existing with the negative ion, and this acts as a initiator. And when it approaches the same monomer, the presence of say these electron donating group, as you have defined here, so electron donating group which makes the monomer to act as a nucleophile, and thereby it easily attacks the electrophile and leads to the formation of carbocation, and this is the active species. This is the beginner or the active species of the monomer, and that is, and the site, say it is on, say the monomer, resulted monomer is a carbocation. It is very active species. Now instead of Lewis acid, there are many number of strong acids which are very good proton generators, but their counter ions are having nucleophilic nature. They are having moderate nucleophilic nature, and if we use such acids, they act as an initiator, but very soon they will terminate the reaction because the counter ions are highly, say they are having moderately nucleophilic in nature, and thereby they react with such ions, carbocations, and they will terminate the reaction. Thereby we get a polymers or a macromolecules with very low molecular weight. Okay, that happens when we use such Bronsted acids. Therefore, Lewis acids are preferred to initiate the reaction or to act as a initiator in ionic, say cationic polymerization reaction. Say when the BF3 is taken, now we get this adduct and it is the initiator, and it gives an active carbocation species. Okay, so now in the second step, once the carbocation active species is formed, it reacts with, say, number of monomers. That means there happens a continuous or successive addition of monomers to the, say, newly forming carbocations. So thereby the lengthening of chain or the chain growing will take place, and you will get a macromolecular carbocation. Macromolecular, say carbanium ion. Okay, so this happens in the second step, that is said to be a propagation step. So in the termination step, there are several methods of under termination steps, and I have explained only two types. Say one is, the first one is, say the beta carbon of the carbonium ion. So when it is transferred to the one of the monomer, and thereby it results in the formation of a new active carbocation which acts as an initiator, and the macromolecule with end with, say the unsaturation, and gives a molecule. Okay, so like this, by transferring the beta hydrogen atom to the monomer, it's the one method, and the second one is that hydrogen atom by transferring it to the counter ion, and thereby the chain can be terminated or the reaction can be stopped. So this will be the spontaneous termination step or method. So thereby one can terminate the propagating chain, or one can stop the growing of the chain, and now the resulting molecules are said to be usually a dead polymer, and here it is a growing polymer, and these are the active species, and here these are the stable or less active inactive species with the liberation of initiator. So what we have taken in the beginning, that will be given out. So catalyst will be released back. So catalyst and co-catalyst, they are released back. So this is about the ionic, that means especially cationic mechanism of cationic polymerization reaction. Okay, thank you. With this we'll continue in the next class.